Right. So let's try to revise the quantum numbers theories. Quantum numbers. So we know the quantum numbers. There are 4 types of quantum numbers. There is n. Why it is writing? Let's take another page. We have n. Wait, there is some problem. There are 4 types of quantum numbers. The number 1 is principal quantum number. That is n. There is principal quantum number. Principal quantum number, the values are varying from 1 to infinity. We have discussed these things in our theory class. Then we have azimuthal quantum number. Sometimes this is called as magnetic quantum number as well. So L values are varying from 0 to n minus 1. Right? Then we have magnetic quantum numbers. Sorry, azimuthal quantum numbers. Then we have magnetic quantum numbers. Magnetic quantum numbers. Magnetic quantum numbers are varying from minus L to plus L, including 0. Then we have spinning quantum number. So spinning quantum numbers are minus half and plus half. Minus half and plus half. So these are the 4 quantum numbers and their values. Principal quantum number is the main energy level. Azimuthal quantum number is sub-energy levels. Magnetic quantum numbers is the orientation of the sub-energy levels. And spinning quantum number is the spinning direction of the electrons. So each and every electron has a unique set of quantum numbers. That is what we have discussed in our theory class. So let's try to figure out some examples on this one. For an example, if n is equal to 1, this is principal quantum number. The L values, azimuthal quantum numbers are varying from 0 to n minus 1. So n equals 1 is having L is equal to 0. So we discussed that L is equal to 0 is S. Right? Then n is equal to 2, that has L is equal to 0 and L is equal to 1 because L values are varying from 0 to n minus 1. This is called as S, this is called as P. Right? So on the other hand, if there are any questions, you can unmute and ask me any questions. Okay. And or you can ask any questions via chat as well. Let me open the chat box as well. So if anybody can't understand this one, just let me know, right? Because we have discussed these things. I just want to revise the things and do the questions. Then azimuthal quantum numbers. These are azimuthal quantum numbers. Magnetic quantum numbers, L is equal to 0, then ML is equal to 0. Here ML is equal to 0. Here ML is equal to minus 1, 0, and plus 1. Right? Then N is equal to 3. N is equal to 3 means L is equal to 0. We have S. ML is equal to 0. L is equal to 1, that is P. L is equal to 2, that is D. So ml here -1, 0 and +1. ml is equal to -2, -1, 0, +1 and +2, like that, right? So we can go until n is equal to 4, 5, 6, 7, like that. We have done this one in the class as well. Based on that, we can uh, define the quantum numbers, principal quantum numbers, asymptotal quantum numbers, and magnetic quantum numbers, and as well as spinning quantum numbers. We can define them, right? So let's go to the tutorial. ඔයාලා tutorial එක නැත්තම් කලබල වෙන්න එපා. මම මේක share කරන්නම්. Where is it? It's tutorial. Tutorial එක ඔයාලා තියෙන tutorial එක තියෙන අය tutorial 3 එක ගන්න. tutorial. එනතත් කමන්න මම share කරනවා ඔයාලට ගාන බලා ගන්න පුළුවන්. Okay. සංශයාවක් නෑනේ. අපි දැන් මේ විදිහට බලමු. stop share කරලා full screen එකම share කරමු. හරි. දැන් අපි this is tutorial 3. තියෙන tutorial එක ගන්න. ඔක්කොම ඩිස්කස් කරනවා. මම අද quantum numbers තමයි ගොඩක් focus කරන්නේ. හරිද? අනිත් ඒවා කරනවා. තව කීපයක් මම කරනවා අද. now අපි දැන් ඩිස්කස් කරන්න පටන් ගමු. මම තියෙන සමහර කීප දෙනෙක් සෙට් වෙලා නැහැ කාමනේ. කාමනේ ටියුටෝරියල් නැත්තම් පුතා කමක් නැහැ මේ අලුත් ටයිප් දෙනවා මේ මම ටියුටෝරියල් ටික දෙනවා ක්ලාස් එකේදී දැනට ෂෙයා කරන එකෙන් බලන්න ඕනේ. let's try to understand this 2024 question. In an atom, right? In an atom, how many orbitals can have the quantum number n equal to 3 and sorry, this was right. N is equal to 3 and ml is equal to 1 and n is equal to 4 and ml is equal to -1, right? So these are the this is the 2024 question, if I'm not mistaken. This is the second question. In an atom, how many orbitals can have the quantum numbers n is equal to 3, ml is equal to -1, that is one set they are talking about, and n is equal to 4 and ml is equal to -1, right? So this is the question. Now let's try to understand, let's try to figure out this question, right? Now if n is equal to 3 and ml is equal to -1, n is equal to 4, ml is equal to -1, right? So let me go to the one more again. If I can split the screen, that would be great. How can I split the screen? Come on. N is equal to 3. ML is equal to -1. The other one is ML is equal to N is equal to 4. ML is equal to -1. How many orbitals can have the quantum numbers? What is it? N is equal to 4. ML is equal to -1. We are asking how many orbitals, right? So let's say N is equal to 3 means L is equal to 0, L is equal to 1, L is equal to 2. Then L is equal to 0 means ML is equal to 0. Here ML is equal to -1, 0, and +1. Here ML is equal to -2, -1, 0, +1, and +2. Now in this set, when N is equal to 3, ML is equal to -1, 1 is here, another one is here. ML is equal to -1. So there are two orbitals when N is equal to 3 and ML is equal to -1. Let's go to the next one. N is equal to 4, then ML is equal to -1, right? Make it clear. N is equal to 0 and L is equal to 0, 0, L is equal to -1. Sorry, L is equal to 1, L is equal to 2, L is equal to 3, right? So here ML is equal to 0, ML is equal to -1, 0, +1. Here ML is equal to -2, -1, 0, +1, +2. Here ML is equal to -3, -2, -1, 0, +1, +2, and +3. These are the ML values. So N is equal to 4, ML is equal to -1, 1, 2, and 3. So altogether, orbitals are 5. When N is equal to 3, ML is equal to -1, ML is equal to -1. In there are two occasions. When N is equal to 4, ML is equal to -1 occasions, 3 occasions. So we are asking in the question, how many in an atom, how many orbitals can have the quantum numbers N is equal to -3 and ML is equal to -1, and N is equal to N is equal to 4 and ML is equal to -1. So answer is 5. The number here, the answer number here is 4. This is the answer, right? Now let's talk about the 2025 question. If there are any questions, you can ask me. Okay. Any questions? Right. 2025. The maximum number of electrons that can exist in an atom with quantum number n is equal to 4 and L is equal to 2 in the ground state is maximum number of electrons. They are asking about electrons. There is a question here. Okay. No, sir. Okay, right. The maximum number of electrons that can exist in an atom with the quantum numbers n is equal to 4 and L is equal to 2. Right. In the ground state. So they're talking about the ground state as well. So the ground state means for they have not excited. That means they have not gone into the higher energy levels. They are in their uh, respective original energy levels. That is the idea of the ground state. Right? They have not absorbed the energy. We have discussed those things. So that is the meaning of this ground. This one, ground state. Right? එකම කතන්දරේ මෙතන තියෙන්නේ. අපි දැන් බලමු කොහොමද මේක කරන්න කියලා. right? මේකෙමයි මේ කතන්දරේමයි තියෙන්නේ. n is equal to 4 and when L is equal to 2, what is the maximum number of electrons of this one? That's what they are asking. So actually, if you check this one, the maximum number of electrons that can exist in an atom with quantum number n is equal to 4 and L is equal to 2 in the ground state. So which means they are asking here, when n is equal to 4 means, that means fourth main energy level. Fourth main energy level means we have 4s, we have 4p, we have 4d, and we have 4f, no? Those are the sub energy levels, no? So S can have, this is L is equal to 0. This is L is equal to 1. This is L is equal to 2. This is L is equal to 3. Right? So maximum number of electrons that this can have, S can have 2. P can have 6. D can have 10. F can have 18. Right? Not sorry, 14. F can have maximum 14. Right? Now here we are asking what is the maximum number of electrons where n is equal to 4 and L is equal to 2. So maximum is 10. So the answer here, 4. Fourth question. Sorry, fourth answer. This is the answer for this one. Right? Very simple things. Right? Make ඇත්තටම 2025 second question. Right? තප්පරකේ ප්‍රශ්න. Okay. Any questions? Right. Now let's go to the next one. This is 2011. These quantum numbers are included from 2011. Right. Before that, there are no quantum number concepts. Your syllabus has been revised or modified in 2011. Right. Yeah, 2011. 2010 was the last batch. Then it was revised again in 2021. Right. Quantum numbers has been added in 2011. Right. That's why this is the oldest question. So here, the number of shells, subshells, right? The number of subshells, sub-energy levels, comma, orbitals. The number of subshells, sub-energy levels, orbitals, and the maximum number of electrons. We are asking about sub-energy levels, orbitals, and maximum number of electrons that could be present in the main energy level described by the principal quantum number 3, respectively. So we are asking about 3 things: sub-energy levels, number of orbitals, maximum number of electrons. Right? So let's go to the n is equal to 3. Right? So when n is equal to 3, 2011. So when n is equal to 3, we have L is equal to 0, L is equal to 1, L is equal to 2. So these are the sub-energy levels. Sub-energy levels. So basically there are 3 sub-energy levels. What are they? This is 3s, this is 3p, this is 3d. Are they? Then we are asking about number of orbitals, right? Number of orbitals. Orbitals means the orientations also should be there, right? That means ML values we are asking about. ML, here L is equal to 0, here L is equal to -1, 0 and +1. L is equal to -2, L is equal to -1, 0, +1 and +2. So these are the orbitals, right? So number of orbitals are, here this is 5, here this is 3, here this is 1. So altogether there are 9. And maximum number of electrons. Each orbital can have 2, right? Each orbital can have 2 electrons because each orbital or each ml have 2 ms values, -12 and +12. So if the number of orbitals are 9, maximum number of electrons is 18, right? So sub-energy levels are 3, orbitals are 9, maximum number of electrons are 18. Then okay, කෙටි ක්‍රමයක් තියෙනවා හොයන්න. If the main energy level is n, if the main energy level is n, number of orbitals is n squared. This is number of orbitals. So for an example, if n is equal to 4, number of orbitals is 4 squared, that is equal to 16. So there are 16 orbitals in the fourth main energy level. So let's say n is equal to 2. So that is 2 into 2. There are 4 orbitals should be there in n is equal to 2 main energy level or second main energy level. We know that one, right? So second main energy level means 2s and 2p. S is having 1 sub energy level or 1 orbital. P is having 3 orbitals. So altogether 4. So from this equation, n squared, this is total number of orbitals. If the main energy level is n, right, maximum number of electrons that main energy level can have is 2n squared. This is maximum number of electrons of n main energy level or principal quantum number. So this shortcut method, but this can be used in MCQ questions, right? So total number of orbitals in a main energy level can be taken from n squared. If it is 4, there are 16 orbitals. If there are 3, there are 9 orbitals. So maximum number of electrons is 2n squared, right? So in that way, you can calculate them. So, so here, so in our question, sub-energy levels are 3. Sub-energy levels are 3. Orbitals are 9. Maximum electrons are 18. So you can use this equation as well. So the answer is 3, 9, and 18. So let's go to our question. 3, 9, and 18. The answer is the third one. Third one. Right. You leave anything. Come on. Right. Yes. Second one. Hmm? Okay. Then this is 2011, 2020, 2012. Any questions? Actually, one प्रश्न ये ना मामला क्या क्या लेना प्रश्न ये ना हम लोग ने अभी मैं क्लास से कराने प्रश्न आ गया ना प्रश्न इधर आ गया ना वेंटी करेंगे नहीं हम मी theory part take kira kan February kutekin mana mana kata karena WhatsApp message dan mau recording sih kan 2012. The identity of an electron in an atom can be expressed using four quantum numbers N, L, ML, and MS. That is something we know. Identify which set of numbers given below is not acceptable as a set of quantum numbers for an electron in an atom. මේක දැන් මේ ලියවෙනවා නම් හොඳයි. ඉතින් බලමු මේකේ මට ඕන විදිහට මම වැඩ කරන්නේ සමහර වෙලාවල්. හරි බලමු ලියේද කියලා. හරි. Now let's take the first one. Right. So the first one is 4, 2, 0, and plus half. Right. So when there is 4, L values are 1, 2, 3, 4 should not be there, right? Because the L values are varying from 0 to n minus 1. So if it is 4, n is equal to 4, L values are 0, 1, 2, and 3. When L is equal to 2, ML values are minus 2, minus 1, 0, plus 1, plus 2, and plus 1 and plus 2. So 0 can be there. And spinning quantum number is minus half and plus half. Yeah, that is correct. So the first one is acceptable one. Let's check the second one. N is equal to 3. L values are 0, 1, and 2. Because L values are varies from 0 to n minus 1. So 1 can be there. ML values are, if it is 1, minus 1, 0, plus 1. MS values are minus half and plus half. So second is also acceptable. Right? Then the third one. Third one, M value is 3. L value can be 0, 1, and 2. That is valid. If L value is 2, ML value can be minus 2, minus 1, 0, plus 1, and plus 2. But plus 3 cannot be there. So the third one is not valid. The third one is not valid. එහෙමයි කියලා අපි දැන් මේ ප්‍රශ්න කරනකොට මේක කරලා ඉවර වෙලා මේක තමයි උත්තරේ කියලා. උත්තරේ මේක දැන් third එක. උත්තරේ මේකයි කියලා අපි අනිත්‍යව චෙක් කරන්න නැතුව ඉන්නේ. අනිත්‍යව තමයි චෙක් කරනවා. එහෙමයි අපි ඉගෙන ගන්නවා කියලා කියන්නේ. Now let's check the fourth one. N is equal to 2. L values can be 0, 1, and 2. Sorry, 0 and 1. 2 is not there. So 1 is there, can be. So L is equal to 1 means ML values are minus 1, 0, and plus 1. And minus half plus half, that is there. Let's check the fourth one. The fourth one is fifth one. N is equal to 4. Then L values are 0, 1, 2, 3. If it is 0, ML value is 0. Then MS value is minus half. So first one, second one, fourth one, fifth one, all of them are valid. Third one is invalid because of that ML value, right? If it is 2 for L, ML values can be minus 2, minus 1, 0, plus 1, and plus 2. So minus 3 cannot be there. So the answer is the third one, right? Okay. So split current flow. Right. Okay. So let's check the next one. Right. 2014, 2013 ഉള്ള പ്രശ്നം ആക്റ്റീവിലാണ് quantum numbers. Right. So the maximum number of electrons having quantum numbers n is equal to 3 and L is equal to 2. May Prasni, this is 2014 and check the 2025 question. Almost same, right? Almost same. In 2025, the question is in our tutorial 30, 32nd question. N is equal to 4 and L is equal to 2. Maximum number of electrons that can exist with the quantum numbers and N is equal to 4 and L is equal to 2. When it comes to the 2014 question, the maximum number of electrons having quantum numbers 3 and L is equal to 2 in an atom. Ground state, right? So, which means when N is equal to 2, right? So, N is equal to 3 and L is equal to 2, right? So, let's say N is equal to 3 means we have 3S, 3P, and 3D. This is L is equal to 0, this is L is equal to 1, this is L is equal to 2. So the maximum number of electrons this can have 2, this is 6, and this is 10. So N is equal to 3 and L is equal to 2. The maximum number of electrons that it can have is 10, right? So for this one, the answer is the fifth question, sorry, fifth answer, right? The maximum number of electrons having quantum numbers N is equal to 3 and L is equal to 2 are 10. So the answer should be fifth question, fifth answer, fifth one, right? Next one. Right? මේ ගාන හදන්න ඔයාලට ඕන වෙනවා periodic table එකක්, but let's try to do this one, right? Periodic table එක තියෙනවා ළඟට ලං කරගන්න ගාන හදමු අපි. The sets of quantum numbers associated with the last two electrons of an atom in an element are 300 plus half and 300 minus half, right? දැන් මේක අලුත් දෙයක් ඉගෙන ගන්න තියෙනවා මේ ගානේ. හරිද? There is a new thing that we can learn here, right? So the new thing is when n is equal to, that means by checking n value, right? N value is equal to the period number, right? Period number of the element, right? So n is equal to 1 means first period in the periodic table. N is equal to 2 means second period. N is equal to 3 means third period. So on the other hand, we can say there is only one main energy level here. Second period, 2 main energy levels. Third period, 3 main energy levels, right? So these are some new things that we can learn. And also we can say first period is having only oneness. That means second period is having 2s, sorry, oneness is there, 2s and 2p. Third period is having 1s, 2s, 2p, 3s, 3p, and 3d. Right? So looking at this one, we can deduce the period and the suborbitals available in each period. Are there? Then, just by looking at the L value, by looking at the L value, you can decide the block of the element. Block. If L is equal to 0, that belongs to S block. That means final electron is filling into the S orbital. Right? When L is equal to 1, that is P block. L is equal to 2 means that is D block. Right? So that means the final electron is filling into 1, that is belongs to P block. Final electron is filling into L is equal to 2, that belongs to D block. So just by looking at the quantum numbers, you can decide from N, you can decide the period. From L, you can decide the block. Right? Now let's go to the question. The question is the sets of quantum numbers associated with the last two electrons of an atom in an element are, we are saying 3, 0, 0, plus half. And the other one is 3, 0, 0, minus half. This is very clear. This element belongs to third period because n is equal to 2. So n is equal to 3. So this is third period. Right? So see, we have reduced that one. It belongs to third period. And also, L is equal to 0 means this belongs to S block. Right? S block means we have first group and second group. So we check the third period first group, second group element third period, first group or second group. Right? Now let's check lithium. Lithium is in the second period. It can't be. First one is lithium. Right? Then sodium. Sodium belongs to the third period. Right? Sodium belongs to the third period. So sodium is a candidate. Right? Then magnesium. Magnesium is also third period S block. Right? Because this is in the third period. Third period and first group. This is third period, second group. Aluminium, third period, third group, but this is in the P block. So aluminium is not a candidate. Then potassium. Potassium is in the fourth period. So N is equal to 4 here. So this is also not a candidate. Right? So out of these two, how we can deduce whether it is sodium or magnesium? Right? Whether it is sodium or magnesium, we have to reduce it. How to reduce it? That has to be done very carefully on this one, right? So here they are talking about last two electrons. Last two electrons of an atom in an element are last two electrons. Antima deka gana Both of those two electrons are in the third period. L is equal to 0. That means s orbital have two electrons. S orbital have two electrons means it has s2 configuration. Me. So last two electrons. There are two electrons. Two electrons are both of them are in the s block or s orbital. That is also in the third period. S orbital have two electrons. That means it has 3s2 configuration. 3s2 configuration, let's say sodium is 11, magnesium is 12. Make up sodium is 1s2, 2s2, 2p6, 3s1. So this is 3, 0, 0, plus half. It has only one electron. This is sodium. Magnesium is 12, 1s2, 2s2, 2p6, 3s2. Right? So this is 3, 0, 0, plus half. There is another electron that is 0, 3, 0, 0, minus half. So which means S is having two electrons. 3s is having two electrons. So which means this surely belongs to 3s2. That means second group. Third period second group is magnesium. So the answer is magnesium here. We learned a lot here. First one is by just taking the quantum numbers, you can decide the period, and also you can decide the block as well. When you are deciding it, you have to decide by using the final two electrons or final electrons, right? So the last two electrons, right? You have to decide it by using the last two electrons or the last electron, not two, last electrons. So if last electron is having n is equal to 4, that belongs to fourth period. If L is equal to 1, it belongs to P block. So likewise, you should be able to deduce the period and as well as the block. അപ്പോൾ ഉദാഹരണമൊക്കെ മേക്കണം 4, 2, minus 2 plus half. So this is the last electron quantum number set. So this is belongs to fourth period. This belongs to L is equal to 2 means what? SPD. So this belongs to D block. Right? D block. And this has minus 2 and plus half. Last electron. Last electron minus 2 plus half now. So let's say L is equal to 2 now. ML is equal to minus 2. ML is equal to minus 1, 0, plus 1 and plus 2. This is having plus half and minus half. So likewise, each of these having 2 electrons. Minus 2 right? So which means that is the first orbital of D. It is having only one electron. Right? Only this one it is having. Let's say for an example, so that means in the D block it is having 4D1 configuration because 2 is starting from minus 2 and minus 2 is also starting from plus half. 4, 2, minus 1 and plus half. This is the last electron for an example, right? Make a beginning number. So this is in the fourth period. This is D block. ඊට පස්සේ අපිට කියන මේ අන්තිම ඉලෙක්ට්‍රෝන එක -1 කියන -1 plus half. එතකොට if this is L is equal to 2, ML is equal to -2, -1 plus 0 plus 1 and plus 2. So If the last electron is -1, already it has -2. There are 2 electrons here. And this is having 1 electron because there is plus half. So this is having the configuration of last electron 4d3. Right? 4d3. මේක ප්‍රශ්නයක් තාම අහලා නැහැ. අහන්න පුළුවන්. හරිද? මේක අපි තව උදාහරණයක් ගමු. 3, 1, 0, plus half. So 1 means P. So this is 3P. Right? So the last electron, if it is 1, L is equal to 1, ML is equal to -1, 0, and +1. So already it had 2 electrons, already were there. 0 plus half means 1. So this is 3p3. So it is in the third period, p block. There are 3 electrons in the p orbital. So this is how you decide it. Okay. So let's go to the next one, that is 2018. Sorry, yeah, 2016 one we have done. So let's go to the 2018 one. So the 2018 one, which of the quantum numbers N, L, M, L, and MS are associated with shape of an atomic orbital in an atom? Shape. Which one is deciding the shape, right? කට්ටිය උත්තර දෙන්න බලන්න මේකනේ because we have done නිකන් මට chat එකේ දාන්න බලන්න කටින් කතා කරලා කිව්වත් කමන්නේ. Can you give me the answers for this one? I'm asking 37th question. Which quantum numbers N, L, M, L, and MS are associated with the shape of an atomic orbital? Shape එක decide කරන්න කවුද? Who is deciding the shape? Is it N or is it L or is it ML? Who is deciding? Let's say. Okay. There is one answer. Okay. 2 answers. What else? Okay. දෙනාගේම එකම උත්තරය ආවේ. හරිද? හොඳයි. අනිත් අය එනවද උත්තර? හරි. අපි මේක දැන් ඩිස්කස් කරන්න බලමු. So N is giving you the idea of main energy level. මේකේ ඔය shape කතන්දරයක් නැහැ. That is giving you the idea of how much of distance is from the nucleus, right? Okay. Let's see, on this one. So L is give you the idea what are the sub energy levels, right? L is equal to 0, so this is S. L is equal to 1, this is P. L is equal to 2, so this is D. L is equal to 3, this is G. Sorry, F. L is equal to 4, this is G. So the L can give you the idea of the shape as well, right? So this is spherical. This is dumbbell. This is double dumbbell. Others I don't know, right? So just by looking at the L values, you can deduce the shapes, right? So L is one acceptable answer. Just by looking at the L, you can deduce the shape, right? Whether it is spherical, double dumbbell or whatever the shape can be deduced, right? And also ML means the orientations, right? Orientations. So by just looking at the orientations as well, you can deduce the shapes as well, because orientation in an indirect way, ML gives you the idea of the orientation, but in an indirectly, you can deduce the shape as well, right? So which means like ML is equal to 0 means that is spherical, right? Sorry, wait, sorry. Well, L is equal to 0, ML is equal to 0. So ML is also gives you the idea of the orientation. When you talk about the orientation in an indirect way, you are discussing about the shape as well, right? So L is equal to 1 means it is dumbbell shape. So ML there are three orientations, right? So orientation again you are talking about the shapes, right? So likewise. So ML is also an acceptable answer. මේ පාර මේ 2018 දී ඔකට හරි දුන්නා පළවෙනි උත්තරයට හරි දුන්නා. හරිද? ඊට අමතරව පස්වෙනි එකටත් හරි දුන්නා. දෙකටම හරි දුන්නා. So the answers, there are two answers here. L, O, L and ML, right? එතකොට අහන්න පුළුවන් ML වලට විතරක් shape එක කියන්න පුළුවන්ද කියලා. No. Just by looking at ML, you can't talk about the shape, right? Why is that? කාටට කියන්න පුළුවන් just by looking at ML, why you can't talk about the shape? Just by looking at L, you can talk about the shape, right? Just by looking at ML, why you can't decide the shape? But combination of L and ML, yes, you can. That's why fifth answer is correct, right? So why just by looking at ML, you can't deduce the answer or the shape? Answer is very simple, right? So when L is equal to 1, we can have -1, 0 and +1, right? So these are dumbbell shapes. So dumbbell shapes. When L is equal to 2, -2, -1, 0, +1 and +2. So for an example, here also we have -1, here also we have -1. So this -1 is double dumbbell, right? So just by looking at ML, you can deduce the shape. But just by looking at L, you can deduce the shape. And the combination of L and ML, yes, you can. So ඒ පාර ලකුණු දුන්නා ওই දෙකට. First question, sorry, first answer and fifth answer, both of them. Okay, right. Right. මම දැනට 2019 මම පොඩ්ඩක් තියන්න මට අපි ගමු මෙන්න මේ ගාන. This question 2024, this question, right? The de Broglie wavelengths of two particles x and y are x and y are 1 nanometer and 3 nanometer respectively. If the mass of x is 3 times the mass of y, the ratio of kinetic energies of x and y would be. මේක හොඳ ගානක්. ළමයි ගොඩක් මේ පාර වරද්දලා තිබුණා. So de Broglie wavelengths, හොඳට අහගන්න. the de Broglie wavelengths of two particles x and y. We are talking about x and y, right? De Broglie wavelength means lambda. X is 1 nanometer. Here this is 3 nanometer. If the mass of X is 3 times the mass of Y, so the mass is M. Here this is, let's say, if this is My, this is 3My, right? Mass is 3 times of, so X mass is 3 times than of Y. That's what that means. If the mass of X is 3 times the mass of Y, the ratio of kinetic energies. So having said that, මේක අපි ඔළුවේ තියාගෙන අපි දැන් බලමු මේක හදාගන්න මේක පොඩි එකක් කරගෙන. So the kinetic energy, you know, so this is half mv square. So this is the kinetic energy, right? The kinetic energy equation. So let's say මේක පොඩ්ඩක් ලොකුවට ගන්න. So x1 we can rewrite as half 3my v squared. V is the velocity. Here we can say half my v y squared. And also lambda is given, right? So if lambda is given, we know the Planck constant relationship, right? Can you remember the Planck constant relationship? So the Planck constant relationship we can deduce very easily, right? So we know if it is a particle, right? If it is a particle, I'm just checking what is the question number of this one. The question number of 2024 is, yeah, this one. This is the fourth question. And also, you know, the Broglie wavelength can be reduced by using lambda is equal to h divided by mv. We have deduced this one. H is the Planck constant, m is the mass, v is the velocity, right? So we can subject v, right? So the v is equal to h divided by m lambda. So this is something that we can substitute. Make x and x y world. So this is half. Let's take it as a ratio, right? 3my. V of x is h divided by mx is 3my. Lambda is 1 nanometer n square into, right, the ratio half my. Vy is h divided by m is my. Lambda is 3 nanometers square. Make up x divided by y කියන එක මෙහෙම අපි දාගමු. එතකොට මේක පැහැදිලිව අපිට පේනවා. Half 3my h divided by 3my squared. Total 1 divided by half my h 3my squared. Half කැපිලා යනවා. These are kinetic energies. And kinetic energy. See, we are asking about the kinetic energies. Kinetic energies of x and y would be. Okay. So my is cancelling off. Then 3mi squared, 3mi squared, h squared will be cancelled off. Okay. So the answer is 3 divided by 1, x divided by y. So if I repeat again, the Broglie wavelengths are 1 nanometer and 3 nanometers, right? So m is 3my and 4my because mass of x is 3 times than the mass of y. So we are talking about kinetic energies. Kinetic energy is half m squared. Half m squared the mass is 3mi4 x, and Vx is, we can take it from this equation, the Broglie wavelength, lambda is equal to h divided by mv. We have done this, we have done many questions on this one. So we can subject capital V, or the velocity can be subjected as h divided by m lambda, then half 3mi Vx squared. Vx squared can be substituted as h divided by m can again 3y, 3mi. Lambda is the de Broglie wavelength. De Broglie wavelength is 1 nanometer. So that's why I have taken it as 1 here. Right? Then when it comes to y, that is half my, h divided by my is the mass, and then wavelength is 3, and that is also square. So we have taken the ratio. So the ratio is 3 into 1. So this is a very beautiful question. So the kinetic energy is ratio is 3 into 1. So the answer is 3 into 1 kilagatina. Yeah, answer is fourth question. Sorry, fourth answer. Fourth one is the answer. Right? 2025 එකත් මේ ගන්න අපි කරමු. මේක කාටද ලියා ගන්න ඕන ලියා ගන්න කොට ගන්න. This one. In the exam as well, this type of working is more than enough. Okay. හැබැයි හරියට කරන්න ඕන මේක තමයි. Right. Now let's go to the 2025 question. 2025. Right. Which of the discoveries given below is Henry Becquerel best known for? Very easy question. 5 seconds question. Not wave particle duality, that is Heisenberg, right? Or de Broglie, right? Then radioactivity, yes, that is Henry Becquerel. X-rays, Rontgen. Structure of the nucleus, that is Rutherford. Neutrons, James Chadwick. You have to remember this. So the answer is the second one, Henry Becquerel, radioactivity, not the X-rays. X-rays not the X-rays. X-rays are Rontgen. Henry Becquerel, radioactivity, right? Okay. So let's stop the class from here for today. Next week also you have the class same time, the question discussion class, right? Same time. ගොඩක් කලා මම පළවෙනි දවස් එක ගන්න. අපි මේ meeting එකට මේ වැඩි build up කරගෙන යමු. Let me stop the recording first.